Okay, graph the function, identify the domain range. Now we got a little bit different thing going on. Now the operation is 2 times x to the second power. Okay, so we're going to make that parent function. We're just going to ignore the times 2 operation, just go with the x to the second power. Okay, so again, you want to put just 3, 2, 1, 0, negative 1, negative 2, negative 3. So if I put 3 to the second, that's 9. And that's going to be 9 here. And then 4, 4, 1, 1, 0. Now, put a parentheses around the x second. Now this is outside, but if it's a multiplication, okay, you know, outside we have been calling them k values, but that's plus and minus outside the function, okay. This is outside, but it's multiplication. That's called an a, okay. So here's what a does. It's kind of like a k. It does the same operation to our y, okay. So I got times 2, I'll times the y's by 2. So 9 times 2 is 18. 4 times 2 is going to be 8. 1 times 2 is 2. 0 times 2 remains 0. 1 times 2 is 2. 4 times 2 is 8. And then 18. Now the reason that matches because let's say we got y equals 2x to the second power. And let's say I replace these, okay? Take your y out, replace it with 18. Take your x out, put a times dot there so it doesn't look like it's 23. Replace it with 3. So 18 is equal to 2 times 3 equals 2 times 3 to the second. So I have the 18 over here. 3 to the second means 3 times 3, which is 9. And then we have 2 times 9, and 2 times 9 is 18. So 18 equals 18. And that's going to happen if you put 2 in for x, you get 8 equals 8, okay, and so forth. Okay, graph it. So x can go by 1s, but on the y-axis, we got to go by 2s so that we can hit positive 18. 2, 4, 6, 8, 10, 12, 14, 16, 18, okay? So 318. 1, 2, 3, 18. 2, 8. So 1, 2, 2, 4, 6, 8. 1, 2, 1, 2. 0, 0 is right in the origin. It's both an x and a y intercept at the same time. Negative 2, 1. It's the only point where it's x and y intercept at the same time. Negative 2, 8. Negative 3, 18. Okay. Now, domain and range is the same thing, but now it's not always going to be greater than, okay? So 0, 0, this one's going to be. So all is your domain, okay? Now you take the y with its center value 0, and that's as low as it can get. The other values I get, the other outputs are higher than 0, so y has to be greater than 0, greater than or equal to. Okay, next problem. Negative 3 times x to the second power. Okay, so we're just going to go with the y equals x second parent function again. And we'll go 3, 2, 1, 0, negative 1, negative 2, negative 3. And if I take those numbers to the second power, we get 9, 9, 4, 4, 1, 1, and 0. Okay, now put a parentheses. Now you have it outside the function, but now it's multiplication. So again, that's known as an a. So again, an a, like a k would, does the same operation to the y, okay? So I will be timesing all of my y outputs by 3. The inputs stay the same because there's nothing in parentheses with the x to the second, okay? X stays the same. So 9 times negative 3 is negative 27. 4 times negative 3 is negative 12. 1 times negative 3 is negative 3. Negative and 0. 0 times anything, 0. Negative 3, negative 12, negative 27, because I've already done those. Okay, x we can go by 1s, but we have to get down to negative 27, so this will be the negative we'll be numbering. We'll number that one by 5s, okay? So negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, okay? So 3, negative 27. 2, negative 12. Okay. 1, negative 3. Negative 3 would be here. Okay. 0, 0. Negative 1, negative 3. Negative 2, negative 12. And then negative 3, negative 27. Now it goes upside down. Okay. And that's going to happen when your A is a negative number. When you multiply things by a negative number, the value switches to the opposite, which means the graph inverts and goes to the opposite. Now this is still your vertex, the 0, 0. Domain still all because the arrows are going each way. Okay. Now the range, you put your Y with the middle, the 0, but now all those numbers are smaller than 0. So now all the outputs are smaller than 0, so it'd be less than or equal to 0 on the range. You can't get anything above a 0. Okay, next one. Y equals negative x to the second. So that's a negative 1. So we're going to start with our parent table, where it's just we're saying what would happen if we took the numbers I'm putting in for x to the second power. Well, 9, 9, 4, 4, 1, 1, 0. Now that's an A value because it's a multiplying number. So what do A's do? They do the same operation like a K would to the Y. So I times all the Y's by negative 1. All that happens when you multiply by negative 1 is the sign changes. If you multiplied by 1, it wouldn't change at all, but negative 1. 0 stays 0. There's no such thing as negative 0. When you have 0, it stays 0. Okay, so 3, negative 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, negative 4. 1, 2, 3, 4. 1, negative 1. Okay, 0, 0. Negative 1, negative 1. Now it comes back around. Okay, so label your vertex as 0. So X domains all, the range, just put your Y with the 0. And again, like the last problem, all those numbers are now smaller than 0. Okay, so it'd be less than or equal to. Okay, Y equals 1/2 times X to the second power. Okay. So again, we're just going to look at Y equals X second. So 3, 2, 1, 0, negative 1, negative 2, negative 3. Now, okay, that's still an A value, even if it's a fraction. And those A values produce the same operation to the Y. Okay, so 9, 9, they start 4, 4. I forgot to put those in, should have done that first. So we're going to times all of them by 1/2. Now, when you're taking number times 1/2, it goes down. I know you think multiplication makes it bigger, but when you multiply by a fraction less than 1, like if you multiply by a decimal less than 1, that number goes down. So that's going to be 4.5. And this one's 4.5 too, because it's 9. Guys, 4 times 1/2, that's going to be 2. Half of 4 is 2. When you times a number by a half, you're just cutting the number in half. That also is 2. Half of 1, 1 times 1/2 is 1/2. That's 1/2. 0 can't be halved. It would stay 0 because there's nothing there to take away. Okay, we're going to go by 1s on each of my axes. Okay, the X and the Y. So 3, 4.5. 1, 2, 3. 1, 2, 3, 4. 4.5. 2, 1, 2. 1, 1/2, halfway. 0, 0. Okay, then it comes back around. Okay, there's my U. And it's a little bit wider, okay? Because when you multiply by a fraction, when your A is a fraction less than 1, it makes the graph wider. If you multiply by a number greater than 1, or greater than 1 or negative 1, it makes it narrower, okay? So 0, 0. Okay. So domain still all, range, you put y with the middle, the 0. You can put x equals, all domains related to the x, but there's no restrictions on what you can put in x and take it to the second power. Okay, all those numbers are bigger than 0. Okay, from 0 it goes up, it increases on each side, so y would be greater than or equal to 0.